47 through 50. Listen to part of a lecture in an engineering class.
Magnetism has many practical applications. One very promising application is in refrigeration or air conditioning equipment. Traditionally, these systems work by increasing and decreasing pressure on a refrigerant fluid. Think of this refrigerant fluid as a sponge, and think of heat as water. When you squeeze a sponge, then put it in a bowl of water, then release the pressure on the sponge, the water flows into it. And then when you take the sponge to the sink and squeeze it, water comes out. Similarly, if you pump compressed refrigerant fluid into a place that you want to cool, when the pressure's released, the fluid draws in heat so the surroundings get cooler. And then you pump the refrigerant to an outside compressor and squeeze out heat to begin the cycle again. This works nicely, but you burn a lot of energy in the process. We can also achieve refrigeration much more efficiently with magnetism. If the atoms in a refrigerant all line up and spin the same way, we say there's a high degree of order. Imagine lines of dancers all spinning in the same direction. That's what we mean by order. Well, by applying a strong magnetic field to certain materials, you can increase the order of the atoms in them. And that essentially pushes heat out of the materials. The heat that's pushed out is absorbed by some kind of fluid and carried away. And then you remove the magnetic field, and your material then absorbs heat from the environment, which cools that environment. And then you again apply the magnetic field, and heat is forced out, and so on.
Number 47. What is the lecture mainly about? Number 48. Why does the professor mention a sponge and water? Number 49. What is the professor illustrating when she mentions dancers? Number 50. What is the effect of applying a strong magnetic field to certain 47 through 50?